Okay, so this is the enthalpy deviation chart. If you look at the enthalpy deviation chart, we see that it's got the reduced pressure over here, which runs from 0.1 to 30. Then it's got the enthalpy deviation, which runs from -5 to 55 on the y-axis. And then if we look at the formula which is here for the enthalpy deviation, H0 minus H, which just means that the enthalpy at ideal gas conditions and the enthalpy at real gas conditions. So which is the difference, which as I said before is how far the real gas enthalpy is from the ideal gas enthalpy, which is divided by the Tc, which is the critical temperature. So if you want to convert your enthalpy deviation to enthalpy to just specific enthalpy, you multiply it by the critical temperature. Then if you want to convert it to kilojoules per kg, you're supposed to multiply it by the critical temperature and then divide by the molar mass. So if we look at, when we go into the chart, we'll see these numbers. This is the TR, which is the reduced pressure. As you can see, the reduced pressure increases downwards. Within there, we also have the saturated lines. So the saturated lines, if you look at this says saturated liquid. So this is the saturated liquid line, and then this is the saturated gas line. Then if we look at this, for example, if we had to look at the reduced temperature here, the reduced temperature in here, when it goes into it becomes constant, the line becomes horizontal, it becomes vertical when it goes into the saturated line. As you can see here, 0.8, 0.8, 0.75. When we come this side, it will be 0.75. So you will see at how we use the enthalpy deviation chart when we do an example.